All right, I think we are 2 minutes in, so maybe we can start now. Hopefully, folks will keep joining in. So, hey everyone, I'm Shivani, and along with Dom here, we'll be presenting on fenced frames. I work in Chrome in the privacy sandbox area. So this is titled Fence Frames Progress because this is based on what we covered in BlinkOn 14, and the slides from BlinkOn 14 are actually linked on this slide. And so we would be covering some of the topics that have been, that the progress that has been made after that, but we'll not be able to cover, all of the topics. So feel free to go into this explainer link, which is right here in the title slide, and see more details for anything else that you're interested in. So this is, keep in mind, this is a subset of topics related to fence frames. So we'd be covering origin and origin keyed stories / cookies, how that works with fence frames, the modes of fence frames, the web platform integration, the spec, and the origin trial progress. And just a recap, which we already covered in BlinkOn 14, what is fence frames? So this is a world where everything is partitioned by top frame site in an iframe, but then there are still some APIs and still some use cases that require cross-site data. For example, interest-based advertising, which is the main motivator of one of our modes. So for those cases where the embedded frame still requires some cross-site information, we want that embedded frame to be isolated from the rest of the page. And of course, iframes cannot be used because they're not that isolated. They can always communicate via post message or other things. And that's where fence frames come in. And then there's a question about the origin of fence frames as to what is the origin of fence frame. Is it the regular origin? For example, if we create a fence frame from a.com, does it get a.com or does it get a unique, non-spaced, opaque origin, like something like Sandbox frames get? So in terms of fence frames, the design decision that we went with is to give them regular origins. But we don't want any fence frame to be communicating with a same origin non-fence frame, like an iframe on the page or another top-level frame, which is the same origin. So we do want some kind of isolation, even with same origin frames, which are not in that same fence frame tree. And we accomplish that by having a nonce in the APIs that are being accessed via storage key. So anything that's being partitioned via storage key, which is including local storage, session storage, broadcast channel, et cetera, service workers, they would all be unique to this fence frame tree because of a nonce. And so there is no communication channel that can get opened up via those to other same origin frames. And that's what this is depicted in this particular diagram, as to the communication can happen within the fence frame tree, but not outside the fence frame tree. And that the non-space storage key also is very similar to how we would do cookies for fence frames. And so cookies will also be non-space partitioned. So they would be ephemeral and they would be unique to this fence frame tree. All right, what are the different modes of fence frames? So as we delved more into the use cases that can be served with fence frames, we realized that one thing that can be constant in all of those use cases is the isolation between the fence frame and the embedding page. So that's a constant across all of these modes, but they can serve various use cases by differing a bit in the way information flows between the embedding page and the fence frame. So our first initial experimentation is going to be for Opaque-ads mode and the default mode, and I'll talk about both of them. The Opaque-ads mode is basically for interest group-based advertising, and we know that in interest group-based advertising, the URL of the fence frame itself is the URL of the ad, which is based on the users browsing across the net. And so this is cross-site data, and we don't want that to be observable by the embedding page. Therefore, this particular mode allows an opaque URL to be given to the fence frame. And so it's opaque in the sense that the embedding page does not know what the URL is. The fence frame and the browser knows, but not the embedding page. And so the information flow is such that, and this is an example code snippet where we are running ad auction, which is a Fledge API. which is our use case for interest group-based advertising. And we can see that the fence frame is being created via a URN UUID, which does not hold any meaning for the embedding context. So the information flow is such that the URL itself carries cross-site data. And because it does carry cross-site data, we need to make sure that anything coming in from the embedding page cannot carry first-party data. Otherwise, those both can be joined together, which violates the privacy guarantees that we want to give. And therefore, we have multiple restrictions on what can be the size of the fence frame created in this mode, etc. And we'll talk about that in more detail later. There's also a default mode that we've given, which is basically there is no cross-site data in that fence frame. And so therefore, there is no restriction on the URL that's coming in from the embedding page because there's no cross-site data to be joined with what comes in from that URL. In our experience, this has been mostly useful for testing, but there may be other use cases for the default mode. So these are the two modes that we are going forward with in our first experimentation, but there will be future modes. In the interest of time, I am not covering those modes here, but they are part of the explainer. There's a modes.md document in the explainer. Switching gears a little bit to how this fence frame integrates with security as currently exists, like permissions, CSP, Sandbox, etc. The principle that we following there is that these security primitives should not allow a communication channel to be created. For example, CSP-EE can have arbitrary data being passed from the embedding context to the fence frame. So we can't allow that. Similarly, policy delegation, we can't allow. So we can't allow these to be used as side channels of communication, but at the same time, we can't allow privilege escalation to be done just by virtue of creating a fence frame. So keeping both of these two principles in mind, we've taken certain design decisions. For example, no permission gated features would be allowed inside a fence frame. And that includes things like geolocation, etc. And then, for example, for CSP, we cannot create a fence frame inside an iframe that has CSP-EE applied on it, because then that would be escalation of privilege, since we can't delegate CSP to the fence frame itself. And CSP itself has a document in the explainer as linked here for more details. And then, for example, Sandbox, what we've considered is that there's a static set of allow flags that will be applied to a fence frame. But other than these, it would be considered a sandbox frame apart from these flags. And these flags were chosen for the Opaque-ads mode based on things we want to allow an ad to do, for example, allowing a top-level navigation by user activation. But we are disallowing things which we don't want in a good ad experience, for example, downloads, etc. And there's a design doc linked here as well. The other part about security integration is opt-in header. We require fence frame to be opted in explicitly by the server simply because there are security primitives like frame ancestors, etc., which cannot be applied all the way up till the top primary root of the page, which we can only apply them to the fence frame root. And so we want the server to explicitly opt in and say that they're okay with that. And then the session history in a fence frame. So fence frames can navigate, but they don't have the same a joint session history with the main page, because that could be a communication channel. And so they have this joint session history from the main page, and they only do replace-only navigations for simplicity. With that, I hand it over to Dom.
Thanks, Shivani. We're also giving fence frames the ability to navigate the outermost document. This is a capability specific to ads, so we're actually limiting it to the Opaque-ads mode of fence frames. And the way we achieve this is by introducing a new reserved frame name called _unfenced top. So it can be used alongside and is similar to the top, the parent, current, self, blank, other reserved frame names, and can be used in the same places as well, such as window.open, anchor targets, form targets, that sort of thing. Now recall that we have the allow top navigation by user activation allowance set when it comes to sandbox flags. And so we actually do require user activation in order to utilize this inside the fence frame. Next slide, please. So speaking of user activation, there isn't too much to say here, but user activation is fenced when it comes to, is fully fenced when it comes to the fence frame. So what this really means is that user activation propagation is not allowed in either direction. So the way this works in the web platform today is if you have a cross-origin iframe and you click on it, it gets user activation, and this user activation propagates outward to all the frames in its ancestor chain, all the way up through the top-level browsing context. If you replace that cross-origin iframe with a fence frame, that propagation is pinned inside the fence. It never jumps the fence and goes outwards and beyond. So that's one way in which we stop propagation. Another way is if you have an outer frame and you click on it, any descendant frame that is also same origin with the outer frame will also get that same user activation propagated to it as well. This is also disallowed in fence frames. Next slide, please. Fence frames have some unique size restrictions as well. The size is effectively immutable after navigation. And if the fence frame is not already sized at a pre-cleared set of default allowed dimensions that we have, then we actually coerce the fence frame size to the nearest set of allowed dimensions and then lock it in from there on out in the fence frame life. These acceptable size dimensions are actual semi-standardized popular advertising sizes that we have now. They're all public, but they're going to be made available more publicly in our specification as well. The way we achieve this is not by actually locking the element size, because we can't make it impossible to resize the fence frame element in every possible way with CSS and other mechanisms. Instead, we just lock the internal frame view. So even though you might be able to resize the fence frame element, that won't ever translate to a resize of the document hosted in the fence frame. So you won't be able to communicate information through the resizing of the frame. But like I said, the sizes are currently, they're public, but we're going to put them in the specification for more visibility. Next slide, please. Speaking of the specification, we do have our specification currently public on our YCG fence frame repository where we're working on it. The spec is in a very early draft at this stage. It's really just a shell of the fence frame element and a few supported attributes. The meat of it, like the processing model and the URL loading and the URN mechanism and the underlying browsing context group architecture is not quite specified yet. We're working on getting that in there, but we're developing all of this in the public on GitHub. Next slide, please. So speaking of the browsing context group architecture, I want to talk about how this kind of works on the web today. So on the web platform, inside of a browsing context group, we have, you can have a top-level browsing context and any number of auxiliary top-level browsing contexts, which for the purposes of this conversation are basically top-level browsing contexts. Next slide. And any of those top-level browsing contexts can have what's called a nested browsing context. So for example, when you create an iframe, the document that is hosting the iframe contents lives within what's called a nested browsing context. And this is necessarily in the same browsing context group as all of its ancestor frames, all the way up to the top-level browsing context, and it concretely contributes to that frame tree. So what exactly does this mean? Next slide, please. Being in the same browsing context group and contributing to the frame tree means that, for example, your load event blocks your parent's load event and arbitrary ancestors' load events. You also have synchronous access to the frame tree structure all the way up through the top-level browsing context that you're rooted at. So you can see, window.parent and window.top and window.frames of your ancestors. You can get some external information as well, like through location.ancestor-origins and document.refer. And you also have the ability to be navigated by or communicate with other frames in the same group, since you're known by name to all of those other frames. You also have the inheritance of various other properties as well. And for all these reasons, we didn't think the nested browsing context concept was appropriate for fence frames. Next slide, please. So what is appropriate for fence frames? As an aside, I want to call out some work that Jake Archibald, Dominic Denicola, and myself are doing. We're basically working on a radical overhaul of navigation and session history in the HTML standard. It's a really large pull request that we're working on, that we're basically trying to separate out the ideas of session history and browsing contexts, top-level browsing context groups and visibility state, and pull these apart in a layering that's more reminiscent of what browsers actually do, and correct how navigation manipulates all of these different properties. Next slide, please. So one of the primitives that we're working on in this sort of spec architecture is this idea of a traversable navigable, and it's very much akin to the top-level browsing context group. The top-level browsing context concept today, and it manages the frame tree inside of it, and as well as a bunch of other things. Currently, our spec design only has something that's called a top-level traversable or a top-level traversable navigable. If that's not a mouthful enough for you. And but we're keeping our design compatible with this future idea of a nested traversable or a child traversable, which is more or less a top-level browsing context and its own top-level and its own browsing context group, but that's nested. Essentially, it's a child of another one. The reason we think this is the right primitive for projects like fence frames and maybe portals as well is because these separate frames they're conceptually separate tabs. I mean, they're almost separate windows that are sort of visually embedded within each other. And as a result, they have a very narrow, auditable communication or set of shared capabilities and communications. And we can achieve that with a new primitive such as this nested traversable idea in a much better way than we ever could with the concept of nested browsing context as it exists today. Next slide, please. So moving from spec stuff, I want to talk just a bit about the origin trial setup and how that's looking today. We are currently launched in Chrome's version 102. We started our origin trial midway through 102's lifetime. We're also running on the beta and dev channels along with the other privacy sandbox APIs. This was all done in the public through the normal Blink experiment and launch process, all on Blink Dev. We are splitting our fence frame population into two segments, 50-50, based on Shadow DOM and MP-Arch. So if you might recall from the last BlinkOn talk that Shivani and I gave in BlinkOn 14, we discussed this idea of the Shadow DOM implementation and the multiple page architecture implementation of fence frames. The Shadow DOM is basically built on top of the nested browsing contexts that have this really, really tight intra-frame tree integration that is not entirely suitable for fence frames, but helps us get something conceptual up and running really quickly. And then the other half is built on MP-Arch, which is sort of this nested traversable idea. Because of the limitations of the nested browsing context mechanisms, our goal is to phase out the Shadow DOM implementation by launch. And so we're currently experimenting with both, and we'll slowly be ramping up the multiple page architecture one to 100% as it becomes more ready. Next slide, please. In terms of metrics, we have a simple use counter tracking all the element uses, but we're also working on adding metrics for various tricky edge cases with fence frames. For example, how often are they unable to be created because of their parent frame having a hostile environment in terms of sandbox flags that is impermissible for fence frame creation? Or how often do we fail to create a fence frame because the mode of the child fence frame is actually different than the mode of its closest relative fence frame? So we don't allow nested fence frames of varying modes. And so we want to keep track of how often are people actually running into that sort of thing. The mode attribute today is essentially immutable in terms of the processing model and what effect it has on the various flows of information in a fence frame. And so we're interested in understanding how often developers are trying to mutate this and maybe use it differently, and what solutions we could provide to make this element more ergonomic, as well as navigation to an invalid URL. There's plenty of URLs that are just flat out considered invalid with fence frames, so we're limiting to things like URNs, HTTPS only, except for localhost, and I think about blank as well. And so we want to know also how often developers are running into a lot of these edge cases. Next slide, please. So since fence frames is very much an architecture project, we're also interested in monitoring the stability of both implementations of fence frames as they're being experimented on in the wild. So we're going to be keeping a weather eye on the stability guardian metrics that we use for Chrome, as well as with our Chrome internal crash tool monitoring the crashes by variation group. So we can see if either architecture or any other privacy sandbox stuff on a larger scale is introducing any specific crashes that we need to worry about. And so we're going to be taking a look at that, as well as the general bug reports that come in and known issues that we're currently aware of before launch. Next slide. I think that might be it. Yeah, so thanks for listening to the talk. There's all of the stuff we described. There's a ton of information. It's all on the GitHub repository. It's just the ycg/fenced frame. That's where our spec is hosted. It's where a whole slew of explainers are hosted, where we describe the security properties, even the goals for process isolation, as well as how it integrates with the web platform. And you can find a bunch of issues for the spec work that's going to be coming as well. Also, feel free to check out the intent to experiment. And with that, I think we're ready to probably open it up for questions in case anyone has any. Otherwise, feel free to contribute more and interact with us on the GitHub repository. And as a final note, I do want to thank everybody that has been working on fence frames. For the second year now, Shivani and I have presented on fence frames, but we're just the tip of the iceberg when it comes to everyone that's really working on it. We have several great teams all throughout the world. I mean, people in Tokyo and Seattle and Waterloo and Cambridge and New York and everywhere, France and London, helping us out with various complexities of a project this large. It's a really cross-cutting feature, and it's as complicated as I probably made it sound when covering the spec stuff. So a huge thanks to everyone that got us to our origin trial milestone and helped us push this past the goal. But yeah, with that, I think we're ready for some questions, unless Shivani, if you have anything else to say.
Yep, happy to take questions. And yes, definitely +1 huge thanks to everyone who contributed. It is a lot of people, and we continue to do that.
Yeah, we're certainly far from launch, but we've hit some really good milestones recently, and very happy about that. But if there are no questions, feel free to take a look at the slides that are linked in some of the BlinkOn 16 metadata somewhere. Check out the GitHub repository, or shoot us an email or even a CL. Oh, looks like Simon from Boku had asked the question: the rationale for not using iframe. That's a good question. So we thought about whether or not. So there were a couple options when it comes to using iframe. We could use iframe and then try and actually base that off of nested browsing contexts, and based off of nested browsing context, and then actually plug all the various holes that we have just by virtue of being a traditional nested browsing context. Or we could have swapped, added an attribute of some sort and swapped the whole entire underlying processing model to be this separate browsing context group, but just sort of under the name of the iframe. We decided that adding an element was relatively cheap and in a better way captured the processing model, since we're going to have several various modes of fence frames, each with separate attributes that are very specific to the fence frame model. So it seemed like a bit of a stretch to overload all the attributes and the name and everything of the iframe processing model for fence frames. That was kind of the decision there, and there's even some discussion of because the mode of a fence frame is essentially immutable, maybe even breaking out the fenced frame element into multiple separate elements that each for one specific mode that persists throughout the lifetime of that frame. That's a possibility that I think we're going to be talking to other browser vendors and spec experts about later. But yeah, going the exact opposite direction with iframe. Yeah, exactly, Steven. With iframe, we thought was a bit tenuous and a bit of a stretch, so we opted against that. And I don't think Steven's joking proposal of fence frame 1 and fence frame 2 would actually work, because the dashes, I think the dashes are only allowed for custom elements, if I remember correctly. Rick asks what the state of the spec work is. The state of the spec work is, basically the current spec is mostly just a really rough shell of the element. We have, I have talked with some people on our team about sort of formalizing our design based on the nested traversables and then getting that up into spec-ease. And that's going to be one of our priorities moving forward now that a huge chunk of implementation work is done. So we kind of have a high-level idea of the design that we want. And outside of the browsing context group layout, much of it is already resolved. It really just needs to be written into some spec. And that's going to be me and one or two other people on our team that's going to be one of the main priorities from here. And then shopping that around with other vendors as well. We've had some preliminary discussions about the underlying architecture with other people from other browsers and spec experts, and we've gotten some good feedback, but that's just very preliminary, so we're ready to take it the next step pretty soon. Stock question on isolated user activation. Have we decided if a click on a fence frame ever carries on the activation state to post navigation, like regular navigation cases? I actually don't know off the top of my head. I do wonder if one of the people from our team is watching and could maybe throw in an answer in the chat if we have the answer off the top of our heads. Otherwise, the best I can probably do is get back to you on that, because I'm not sure off the top of my head. That's a good question.
Sam's next question is about an unpartitioned storage mode. Yeah, that's being, I think that's in the explainer stage at the moment with Daniel McArdle. He's working on the explainer and figuring out how do we make sure that the URL that's coming in is not carrying 1P data, and then what kind of permission prompt, etc. should be there. So yeah, it's yes, hopefully before 3PCD, but I'm not completely sure of the timelines there.
Will it support lazy loading? That's a good question. So I think that means the lazy load or the loading attribute on the fence frame element, not will it support lazy load inside of it. That's a good question. We haven't actually discussed this at all yet. I think that would be an interesting proposal, and I'm, off the top of my head, supportive of it, unless there's any, big thing I'm missing. That seems interesting, and I think it just needs a little more discussion. If you want to help jumpstart that, feel free to file an issue against the repository. But yeah, feature creep, exactly. Yeah, more stuff, please. Cross-vendor support is currently nothing right now. We have shopped the idea of the underlying architecture around to some other browsers, but as far as we're aware, it has not been implemented elsewhere. But that's going to be one of our main priorities from this point on with working on the spec is trying to formalize what consensus on this feature looks like and how that's all going to look.
Yeah, just to add there, so Edge does support, because Microsoft has another proposal for interest group-based advertising, similar to Google's TurtleDove. They have something called Parakeet, and they do want fence frames to be, the rendering ad frame for that proposal as well. So at least we have support in terms of use cases from Microsoft as well.
Sorry, I misunderstood. I was thinking support as in like implementation is done. But yeah, we haven't asked too many other browsers for their formal stance on it yet, but we do have the Microsoft Edge, like Shivani had mentioned. Cool. Thanks for all the great comments. I think we're over time if my calendar invite is correct. So yeah, with that, feel free to shoot any more questions in the general event chat, and we'll be happy to answer them.
Yeah, and thank you for all the great questions. And we're also open to figuring out more use cases and figuring out how fence frames can work for more use cases. So we're happy to hear those as well. All right. Thank you all.